table convert. Okay, so I don't think we have covered this part. So suppose there is an employee, and the attribute of the employee is employee ID, employee name, and then there is something called a date of birth, and then there is another attribute that is referred to as derived attribute. Okay, so that is given as this one, and there is something called age. Okay, so when this particular ER diagram is given to you, how do you convert this ER diagram into a table? It's very simple. So just keep in mind that whenever you are converting ER diagram into table, in the case of derived attribute, you do not need to put derived attribute as a column in the table. Okay, so the answer to this will be EID, name, and DOB. Okay, so keep that in mind. Whenever you have a derived attribute, you do not need to put the derived attribute in the table. Okay, so why? Because you can already derive the attribute from the date of birth. And if you want to derive it, you can just write a query like you can write sysdate minus age or sysdate minus date of birth. You will get the age of a particular person. Okay, so that is why if you want a particular person's age, you can write this particular query and you say that you can name it as age. Okay. So in conversion, there is no need to include the derived attribute component. Okay, so keep that in mind. This case was missed previously. So moving on to the relational algebra part. So I think it is not covered, so I'll include this one. No, it should be at the end of it. Okay. So relational algebra is one of the most important component of your database management systems, and again, it is very. If you understand this algebra part, you will get to know that how your SQL language works. It's as simple as that. So now, if I say that the introduction of a query language. So there are two types of query language that we will study. And if you see here, query language is mostly referred to as a SQL. Okay, SQL firstly was pronounced as SQL, and here it was sometime it is referred to as structured English query language. Okay, so previously it was referred to as structured English query language. Okay, so now it is only changed to SQL, so it is structured query language. Okay, so again the query language can be of two types, that is of procedural query language and non-procedural. Okay, so in procedural is that if you are able to design an algorithm for a particular problem. Okay, so suppose if you want to make a cup of tea, or if you want to just simply take any problem, like you want to inverse the list, reverse the list, reverse the items in the list. Okay, so then you will perform a particular steps to do that particular part. Okay, to do that particular uh, problem. Okay, so now in non-procedural, non-procedural is a bit different. Okay, so it will not tell that there is no algorithm for it, and it just you say that do this particular thing. You will not tell how to do this thing. Okay, so in procedural language you will tell what to do and how to do it. In non-procedural you will only tell that what to do. You will not tell the particular thing that how to do this particular stuff. Okay, so now this is the difference between this. So in procedural language, the user instructs the system to perform a series of operations to produce a desired result. And this is the example of that, making a cup of tea. So if you are, there will be a step-by approach of making a cup of a tea. You will say that just take a pan and put on your stove, gas stove, and then switch on the gas stove, and then put water, put tea, whatever is it, and so on. Okay. So if you're seeing here, you are able to develop an algorithm, and you are telling a particular person what to do and how to do it. Okay. But in non-procedural case, you will not tell how to do it. You will just tell what to do. Okay. In database, it is referred to as that the here user tells what data to be retrieved. It will not tell that how to retrieve this particular database. Okay, so if you are just telling someone to make a cup of tea and not telling the process, the example will be like that. Okay. So now the relational algebra conceptual language query is another one. So theoretical mathematics system or query language to store and retrieve data is referred to as conceptual query language. So whatever we are doing is completely theoretical. We are not coming in the practical age. Okay, so just let me move to the one note. Okay, so there are so two or three basic concepts that I want to tell you. There is something called a relational model. Relational model, you already know what is a relational model. Relational model is when you are storing the thing, you are storing the database in the form of tables. Okay. So to make particular operations on it, there is something called a relational algebra, or your tuple calculus or relational calculus. Okay, so there are two particular things, two particular concepts that are available to implement or to do any kind of operations on relational model. Okay. So all of this, whatever you are seeing here, is a theoretical concept. Everything is theoretical here. The implementation of it is referred to as, the relational model is referred to as RDBMS, and the practical implementation of these relational algebra and calculus is referred to as SQL. Okay, so keep that in mind. The practical implementation of the concept that we will study in this will be RDBMS, so relational database management, and the practical implementation of relational algebra is your SQL. Okay. So now again there is two things here, the relational algebra and relational calculus. Now relational calculus is again referred to as non-procedural language or query language, and relational algebra is referred to as a procedural language. So it will tell you what to do and how to do it. It will only tell you, the relational calculus or tuple calculus will only tell you what to do. It will not tell how to do it. So now another thing is that your relational algebra is based on set theory. Okay, so your relational algebra is based on set theory. Now there are mostly two concepts of set theory that we will use. The first concept of set theory is a definition of a set. Okay, so what is it? So a set can be defined that in a set the no element can be repeated. Okay, so set can be defined as a set in which no element is repeated. It is referred to as a set. Okay, so A is a set, B is not a set because 1 and 1 is repeated. Okay. Uh, Again, keep that in mind. I'm not talking about multi-set theory. I'm only talking about set theory. So in multi-set theory, there may be possibility of repeating the element, but in set theory, there is no possibility of repeating. So relational algebra is based on set theory. This is one thing you have to keep in mind. Another concept is relations. So again, there may be most there will be many confusion here. So let me again clarify here. So in ER, there is a relation. In RDBMS, there is a relation. And in set theory, there is also something called a relation or relation. Okay. So every relation in every, what do you say, concept mean a different meaning. Okay. So a relation in RDBMS means a table. Relation in ER means a relationship. Like a department manages or works for. This is the example, manages or works for. This is referred to as your relationship. Now relation in a set theory is a subset of a cross product. again. So it's a subset of a cross product. Now what is the meaning of it? Now suppose there are two entries of set. So there are two sets of name and age. You just wait for 1 second. Okay, so what is the meaning of a relation? It is a subset of a cross product. So names, like suppose there are names A, B, C, and there are ages like 1, 2, 3. That is given to you. So you already know what will happen if I cross product this A1, A2, A3, B1, B2, B3, C1, C2, C3. There will be 9 particular rows there if I do that. Okay. So now I will write A1, A2, A3, B1, B2, B3, C1, C2, C3. So what is the relation here? The relation in set theory is referred to as a cross product. Okay, so what it means is that when you do a cross product, the answer will be something from this one. Okay, so if it is the set we get, whatever is the subset will be the output. Okay, subset based on the condition. Okay, suppose I'll say that we are what I can say here is that you can filter out those particular rows where the age is equal to 1. Okay, so where the age is equal to 1. So that is what relation in set theory means. Okay, so set theory is that you take a cross product and then you take a subset of it, that will be the answer. Okay, so these two concepts will be thoroughly used in our uh, relational algebra part. So keep that in mind. Now I'll start it by using the different operators that we will use. Operator very much here. So which are the operators that we will use? First operator is projection. Then there is another operator, selection. Then there is another operator, cross products. You already know this. Then there is union, set difference or minus, and there is a rename operator, rename. Okay. So these are the symbols that are attached to it. And projection and selection operator will be unary. Unary means that they will be only applied on a single table. They will not include 1 or 2 or 3 tables. And multiply these set operations will be your binary operation. So they will be employed on 2 or more tables also. So So mostly it will be two tables, so that is why I'm calling these operator as bind. Rename will also be applied on a single table. So you want to rename a single table, you can say that this rename operator is a unary operator. Okay. So there is another operators as well, but they are implemented with the combination of already present operator. Okay. So suppose if there are other operators like intersection, join, and division. Okay. So intersection, join, and division. So they are implemented with the help of operators that is already defined above. Okay. So if you implement an intersection, you can directly say that you implement a set difference operator like a minus b. I'll show you with the example. Similarly, join is implemented by the help of what do you say, select followed by cross product. Similarly, division is implemented with the help of projection, multiplication, and a minus. Okay. So I'll show you this part, that intersection part. Suppose first you have to know how the set difference also works. Okay, so first you have to know set difference. Okay, so what is set difference? Suppose this is a set A, 1 minus 2, 3. Then there is a set B, 2, 4, 3, 5. Okay, something like this. Now you're saying set difference A minus B. Okay, so you write 1, 2, 3, 2, 4, 5. Whichever is common, you must just delete that part, and whatever is resulted in the A part, because it is A minus B, so you write 1, 3. So that will be your answer. If you want to do B minus A, you write B front, it will be 2, 4, 5 minus 1, 2, 3, and whatever is common in this, you cut those part and you write the remaining part as it is. So answer of it will be 4, 5. Okay, so again there is a definition of set difference. Set difference is that if you are doing A minus B, it will say elements of A which are not in B. Okay, so which elements of A which are not in B? So suppose this is 1, 2, 3 and 2, 4, 5. Okay, so A is 1, 2, 3 and B is 2, 4, 5. What are the elements of A which are not in B? I think the elements of A which are
One,
not in B
three.
is 1 and 3. Yeah. Yes, any doubt? So again, it is based on the definition. You can do it like this, or you can just simply cut the part and you write the forward part. So now how intersection is implemented here? Intersection is implemented like A minus B. Okay, so they are not implemented that what is common, but in SQL or in a relational algebra, we implement the intersection part by using the already present operator. Okay, so we are only using minus operator. So just write the sets here. What is set 1, 2, 3 and 2, 4, 5. So you write 1, 2, 3 here, and you write 1, 2, 3 and 2, 4, 5. Okay. So what is the answer of it? It is you minus 2 here from here. It will be 1, 3, and 1, 2, 3 minus 1, 3 will be 1. It is minus from here. 2 is minus from here. It is 2. Okay. So the intersection between A and B. What is the intersection between A and B? So intersection is a common part. So 1, 2, 3 and what is B? 2, 4, 5. So what is the common part? 2 is the common part between these two sets. Okay. So you can implement this by using this operator, or you can. There are another ways also. Okay. So still, I'm telling you that there is no need to what do you say? Uh, use intersection differently. So intersection is actually implemented with the help of a set difference. Okay. Similarly, join is also implemented with the help of a combination of this select and multiplication. And the division operator is also implemented with the help of a projection operator, multiplication operator, and set difference. I'll tell you when I come to it. Okay. So now moving on forward with our selection operator. Keep that in mind that this selection operator looks very similar to the select command in SQL, but actually it is not. Okay, so keep that in mind. So it is also denoted by a sigma, and another it is also referred to as horizontal partitioning. We just wait 1 second. Again, I'm telling you to inform your friends to join this lecture as well. There will be a weekly quiz in this one as well. Okay. So now the selection part, I can take an example so that it will be easily. So M table, you can take it. In the M table, there is something called a number in M department number. It's very easy to implement, or I'll say that D number is easy for me. And then there is something called a salary. So you can include any entries here. So I'm just including the entries to show you. So 1, 2, 3, 4, 5, 6, more than one. Name A, B, C, D, E, F. Salary something like 10K. Okay, so when you want to implement the select operator, how can you do it is that you can just take the select and then you write the table name select from M. Here D number is equal to 1. Suppose you want to select department 1 employees. Okay, so what will happen here is that whoever employees belonging to department 1 will be filtered out and the result will be that part. Okay, so what is the result here? Who depart who particular employees belong to department 1, this will be these two particular departments. So those two rows, okay, keep that in mind, those two rows will be filtered out and your result will be that. So keep that in mind whenever you're using a select operator. There is something called a horizontal partitioning. That is why it is referred to as a horizontal partitioning. Why? Because what it do is that it does not say that I want to take a particular column. Rather than it will say that I will take those employees. I will take the records of those employees who are belonging to department 1. Okay. So it's as simple as that. You can also what you say use a nested query as well in this one. I hope you know nested query. It's very simple. You just write the inner query and then you write the outer query. So suppose I'll say that I want to filter out those employees who have what do you say salary more than 10K and they belong to department 1. Okay, so I'll write the nested query as so internal. I will write the select from employee where suppose salary is greater than 10K, and then I write the outer part select whatever is the answer here, select department number 1 from the answer. Okay, so again this is the first query and this is the second query. You can also write it with the help of an and, but I want to write this like that. Okay? This is the first query, this is the second, this is inner query, this is outer query. You already know how to do it. This is called a nested query. Okay, so now the first will give you how many tuples it will give you. So first it will give you this one. So I'll highlight this one. Okay. So what happens is that for the first one, salary is greater than 10k is this one, this one, this one, this one, this one, this one. Okay. So first query will result in 1, 2, 1, 2, 3, 4, 5, 1, 2, 5. Okay. So 5 tuples. First query. Okay. Now the second query will result in those employees that are belonging to one. Okay. So from this particular tuples who are belonging to department one, only this part. Okay. So the answer will be this particular row or this particular record. So you may be thinking you can also use an AND operator. Just I want to tell you that you can do it with the help of nested query as well. So now one thing that I want to show you that is referred to as something called a commutative property. Okay, so what I do, what will happen if I reverse this particular thing? Okay, so I'll say that select from employee where department number is equal to 1, and then select those whose salary is greater than 1. Okay, so will this result in the same answer? Will the answer of this second query will also be same to the first query? Is it? To check it. So I'll just delete this part. So now check. Firstly, we have to execute the first query, that is the inner query. Inner query say you have to filter out those part, that is where the department is equal to 1. So we will get this particular rows, and from this department you have to go to the outer query. From this result you have to say that whoever has the salary greater than 10k, who has the salary greater than 10k, that will be an 11k. Okay. So the answer, if you are seeing here, answer of both of the query is same. Okay. So this and this are equivalent query. So I can say that what I can say that selection is commutative. What is the meaning of commutative? Suppose there is a plus operator. Okay. So if I can say that r plus s is equal to s plus r, then I can say it is commutative. Okay. The plus operator is commutative because you can reverse the actions, you can reverse the what you say order, and the result is similar. So similarly, if I say that the sigma and I applied some condition A, and then sigma I applied some condition B with the relation is equivalent to sigma, I have reversed the condition. Here B and then here A, and if the result is equivalent, I can call that selection is a commutative. Selection is a commutative operator. So keep that thing in mind that selection is a commutative operator. You just wait a second. Can you tell me which part, the selection part? Which part I repeat? You can just type it. I'll repeat it. You can just tell me which part I'll have to repeat. Okay. Okay, I'll repeat the selection bar in the table. Don't worry. Okay. So now see here, I'll just have written the table here. Nothing more than that. So selection operator is used to what you say select the rows. Okay. So this is the example of the selection operator. Now what here we are doing is that okay. So now what here we are doing is that I'm saying that select from employee where department number is equal to 1. So what is the output of this query? The output of this query will be those particular employees that are belonging to department 1. The resultant will be in the form of rows. So the answer will be 1, 2, A, B, 1, 1, 10k and 11k. So it will not be like that you will get only one column or two column. You will get all the rows in a particular record. Okay. So keep that in mind. It's very simple. You write select and then you write the table name and then you write the condition here. So this is the condition. Okay. So now another thing is that you can also use select operation as a nested query. Okay. So how can you do it is that by using this particular thing. Okay. So here it is written, I'm saying that select those employees, select from employee where salary is greater than 10k. So because it is a nested query, so inner query will always be executed first and then the second query, that is your outer query, will be executed first. Okay. So now what is the result of the first query? So the result of the first query will be those employee who are having a salary greater than 10k. Which are those employee? So these are those employee who are having the salary greater than 10k. Okay. Paste it. Okay. Now the result of this query, the first query is this one, this one. 1, 2, 3, sorry, 2, 3, 4, 5, 6. Yeah, because 10k, yeah, yeah. So it is 2. 10k greater than, we have got that, and you just replace this particular bracket with this particular table. Now what we are doing, I'm saying that from those who have a salary greater than 10k, you have to select those those person that are belonging to department 1. So only this particular row or this particular record, that is employee number 2, is belonging to department 1. So everything is deleted, only this particular thing will remain. Okay. So this is the answer when I do this, what you say, a nested query. Similarly, I have performed the same operation, just I have reversed the department number in the internal query and salary at the outer query. Now what happens with the department number 1? So when I say that select those employees who are belonging to department number 1, these particular rows will be filtered out. Okay, so these one, because these two particular entries belong to department number 1. Out of these, I want those who have a salary greater than 10k. So this particular row will be filtered out. Again, the answer will be 2b 111k, 2b 111k. So what I'm saying is that the first query is equal to the second query. So there is no difference in it. Only I have changed the order. So by changing the order, the answer is not affected. Okay. So if this particular thing happens, then I can say that selection is commutative. So what actually is a commutative property? When you reverse the order. Okay, so suppose plus is commutative because if I say r plus s or s plus r, the answer will be same. So I'll say 10 plus 4, 4 plus 10. If the answer is similar, I can say plus is commutative. Yeah. Similarly, if I say that here sigma A and sigma B, and I change the order of outer is sigma B and then inner is sigma A. If the answer is equivalent, I can say that the selection operator, that is sigma, is commutative. So till here, if anybody has any doubt, just repeat. I can again repeat the whole concept. Tell me, let me know if there is any doubt. Just wait for 1 second. Okay. So now with it, there is something called cardinality. So if you remember what is cardinality in relation is that the number of rows you will get. Okay. So cardinality in case of a selection operator is denoted by this particular thing. Okay. So if I say that if I apply selection operator with a condition on a relation R, what is the maximum number of tuples and what is the minimum number of tuples I can get? Okay, so minimum number of tuples and what is the maximum number of tuples I can get? Okay. So minimum number of tuples. Suppose I'll say that I have to write this condition. How many minimum number of tuples if I can get if I apply the selection query. Okay, say taking the same table. Let me take the same table. Yeah. Now, if I say that select department number is equal to 4 from M. Okay. So if you're seeing here, there is no department number. So what will happen? There will be 0 tuple that will be selected. So minimum number of tuples or minimum number of rows I can select is 0. Okay. So keep that thing in mind. Minimum number of rows in case of a selection operator. Yeah, selection is always commutative. Okay. So selection, that is why I've said this property is commutative. Selection is always commutative. If you reverse the order, the answer will be same. Okay, so there will be other operators that may not be commutative. I will show you. Okay, so what happens is the commutative case, and another thing is that suppose if there are 100 possible scenarios, in all of the 100 possible scenarios, if I can call selection a commutative, only then if the result is similar by changing the order, only then I am calling selection operator as commutative. Out of this 100 scenarios, if only one is not satisfying the order part, then it will not be commutative. Okay, so keep that in mind that if all the possible combination by reversing the order, all the possible combinations, the result is similar, only then I'm calling a selection a commutative. If there is only one possibility that is not following, that by reversing the order the answer is not same, I cannot call anything a commutative. Keep that in mind. Okay, so in coming operators I will show you those scenarios. Okay, so there may be scenarios where commutative property holds, but I will, when I am saying commutative, in all the possible combinations, out of thousands of combination, lakhs of combination, it will be commutative. That is why I have said commutative. Okay, so in other operators like projection, it may not be commutative, so I will only show you that scenario where it is not commutative. So keep that in mind whenever you are using any property, any property. That is why in plus operator, plus is always commutative. You can take any kind of a combination of plus, it will always be commutative. But if there is a single possibility exists that when you reverse the order the answer is not similar, and you cannot call a operator commutative. Keep that in mind. Okay, so in your books it's directly written commutative. I'm showing you the operation that why it is commutative. Keep that in mind. You may have heard the commutative property in your digital electronics as well. So there are other operators like not, or there is commutative property, associativity property. You may have heard about these terms. Okay, so again, if you not, just let me know. Now another one is the maximum number of tuples that are possible. Okay. So the maximum number of tuples that you can get is all the tuples. I can directly get all the tuples that are present in there. So how can you get it? If I write the query to get those employees who have a salary greater than 9K. Okay. So if I write select salary greater than 9K from M. Okay, if I write it, all the tuples I can get. So minimum number of tuples I can get is 0 tuples, and maximum number of tuples. Tuples here means records. Okay. Records here means rows. Okay. So maximum number of tuples that I can get is what do you say? All. Okay. So what is it? All means 6. So I'm writing it as R. Okay. R. R means all the relation. All the relation. So keep that in mind. The range of the selection operator lies with the range of the selection operator will be between range of the selection operator will be between 0 to maximum, all the rows that are present. So keep that thing in mind. Another thing is here that you can also use and or not or comparative operators as well. Suppose I can also write it like this: selection, and there is a condition, and then this is a relation. Okay, so now selection, the condition here will be a greater than 10, And you can also write and here, and or not, b less than 40, and then there is a relation. So it can happen, there is no problem in that. Okay, so you can use and or not, as well as comparative operator like a is equal to 10, a equal to a not equal to 10, something like this. You can use it. Okay, logical operators you can use it, comparative operators you can also use it. Keep that in mind. Okay? So if we seen this particular query in the previous one, this particular query can easily be done with the help of a and operator. This one, where department number is equal to 1 and the salary is greater than 10k. But I want to show the commutative part, that is why I've shown you with the help of a subquery part. Subquery is already covered in your labs. If it's not, it will be covered in the coming labs. Now just open your LMS and I'll give you the quiz part. Okay, just let me see if it is visible to you or not. So inform your friends as well. I'll just share you the